Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is not a main dish, but a bunch of small tapas. We're going to develop a bunch of small plugins that are utility plugins. They are quite simple, but we are going to develop many of them and learn about how they work, but also what they can be used for. And I'm talking about here about a DC offset, a converter of multiple channels to mono, a converter from the left channel to the right channel. So copy the left channel to the right channel, or copy the right channel to the left channel. These are useful when you have some kind of signal that is one-sided. If you're recording something in stereo, but actually you are only recording on the left side or the right side, and the other side is just mute, or in any other case, this is an effect that comes with, I think, Adobe Audition. In any case, we also talk about a stereo mixer, a null tester, a mid-side encoder and decoder, and a gain plugin, though we kind of already covered this already in another episode, but we are going to talk about the principle behind it again, because I'll also talk about an effect to invert the phase of a signal. And then I'll talk about an enveloper, something that does envelopes, that changes the volume in time, and also a rectifier, both half and full rectifiers, and a limiter that is a kind of hard clipper. So it's a simple kind of limiter, but it is useful in some contexts. Okay, so we have a lot to cover, and I'm not sure I'm going to cover everything in this one video, but that's the ground that we want to cover. Those are the small tapas that we are going to talk about. Let's start with DC offset. And to talk about DC offset, first I want to create another plugin, another audio effect, just for the purpose of demonstrating the DC offset. And that is going to be similar to a white noise generator, which we already covered in another episode. So if you want to learn more about not only how to create white noise, but also why it works the way it does, why doing the thing that you do creates white noise, then you should check the other video on this channel. And if you are new to developing plugins or audio effects for Reaper, then you should definitely check the other videos in this channel, in which I introduce you to the idea of JS effects and how to get around the interface and everything. But okay, so let's get started. The effect that I want to create here is a broken white noise generator. So I'm going to scan for plugins and find my white noise generator. That is our version, not the one that comes with Reaper. And I'm going to assign it to a track, just so I can come here and copy this code, because I'm not using the white noise generator. I'm going to use a broken version of the white noise generator. So I'm going to create a new JS effect, and I'm going to call it broken white noise. I'm going to paste that code, but I'm going to break it in a way that I forget to subtract 1. So the idea here is that the random number that creates white noise is a random number between 0 and 2, but we would like it to be a number between -1 and 1. So we subtract 1 to fix that range. But now in this broken white noise generator, I forgot to do that. So what happens here is, let's save. And now this is creating a whole lot of noise that I will have to remove this in post, because I forgot to do the thing that we should always do, which is to mute the master track. So I'm leaving here a note to remember to remove this in post so you won't blast white noise out of your ears. Okay, so now we have a reasonable white noise at -18 dB. And you can see that I'm not physically wearing my headphones, which is a smart thing to do when you're programming audio effects, because you never know when you are going to forget to mute the master channel and blast some loud noise out of your headphones. Just another safety measure. Anyway, broken white noise. This white noise is creating signal, but let's put our oscilloscope, which we created in another episode. So let's put our oscilloscope here, and you can see that it is creating white noise only above the 0. So we can pause and zoom, and you can see that it's creating white noise, but it's always above 0. And that is a DC offset. What is DC? It's direct current, because I think this term comes from electrical engineering when they are talking about literal energy or literal electricity voltage going through the wire. So usually it's AC. The sound waves are the kind of electricity that goes through the wires to power speakers. It's usually AC, alternate current. So sometimes it's above 0, sometimes it's below 0, and it is making your speaker cone move back and forth. So that's why it goes above and below 0. And usually you would see the numbers or the voltage going from -1 to 1, and that's how we represent this in JS effects. But in this case, it's wrong. It's going from 0 to 2. And that may happen when you have some kind of gear that is broken, that has an issue. It's not well calibrated. It may not be as severe as this example here, that is completely off the chart, completely above 0. But in some cases, it's just a small, tiny fraction that is wrong. And you want a DC offset effect to fix that, to bring that value back down. So what we are going to do is, I'm going to enable this again so we can see this in real time, and I'm going to keep it here. And then I'm going to create a new effect that I'm going to put between our broken white noise and the oscilloscope to fix that DC offset. So I'm going to add an effect that is going to be a new JS effect. So you can already see that we are creating a bunch of effects in this episode. So this is a DC offset. And I guess I forgot to mention why it's DC. That's because we are taking direct current as if the wire was taking direct current, not alternate current, and just offsetting it up and down. So we are taking that whole wave and just bringing it down or up in this oscilloscope. Okay, so now we have the DC offset. I'm putting it between the broken white noise and the oscilloscope so we can just see the effect right away. So what we want is first to get rid of boilerplate, and now I'm going to do something to every sample. And I guess I could do this just with stereo because that's the current track that we have. It's stereo, but it's so simple to make it multi-channel, and it leads to less repetition of code, as I already mentioned in some other episodes. So that's what I'm going to do. I'm going to create a DC offset that is multi-channel. And that's because I hate having to write code like this that does something and then does something again to the other channel. I think it's more elegant to just loop. Do the same thing for every channel, and we get a multi-channel plugin for free. Okay, so I will do a loop that starts with channel -1 and loops for the number of channels, and then I am going to add 1 to the number of channels. So that is the setup for the loop. And then the sample for that channel will be the sample for that channel minus equals 1. So what this is going to do is just bring that signal down 1. 1, that's the number that is here. That's the absolute value, the constant that we are using to do the offset. And that is the broken part of our white noise generator. So now I save this, and yeah, this is going a whole lot down. And that is because I am doing the amplitude, the gain, to bring this to -18. So if the plugin was generating, the broken white noise generator was generating something that was 0 dB, then this would fix the problem. So let's see. I'm going to bring this here again. And I'm going to comment this. So it has no effect. Now it's going from 0 to 2. And if I bring this in, then it fixes the problem, brings it down so that it's around 0. But of course, because we have the gain, it's offsetting the whole thing differently. But there is a solution for this. So I'm going to, again, bring this down to minus 18 dB. And the master track is still turned off, so we won't be able to hear anything. And that is good. But now let's create a slider so the user can say how much they want to offset. So I'm going to bring back here this part of the code and create a slider. That slider will be the offset, and it's going to start with 0. So when you load the plugin, it has no effect. And I'm going to allow it to go from -2 to 2 in steps of 0.01. I guess maybe even 0.001. That's because some equipment will have just a small problem and you want to fix that small problem. So now you save this. And of course, we want to use this offset like so. So now it has no effect because the offset is supposed to be 0. Let's see if it is 0. Yes, it is 0. And I can easily bring things up and down. And then I can manually eyeball it and bring it to the middle. Okay, so now this is working. The DC offset is working, but I want to hear the effect that it has on the audio because honestly, I have no idea what it does acoustically. I don't know if it changes what you hear. So I'm going to put in the headphones now, and I am going to make sure that this is very quiet. And I'm going to disable the DC offset by doing this. And now I can come here to the mixer and listen to this. I'll be honest, I don't hear any effect. So I don't think that a DC offset fixes anything that you can hear. But what it does is it changes the gain that you see here. You're metering this signal, and as far as the meter is concerned, it's as if you had a wave that would go from here to here because that's your peak, and it doesn't know that there is a DC offset in this signal. So this meter is just wrong because I was moving the thing around and I could not hear any change in volume, but I could see the meters going up and down here. So I suppose that other kinds of effects that would alter the level of the signal would be thrown off by a DC offset as well. So you can think of compressors, limiters, and anything that has to do with dynamics or metering would get the levels wrong because it would think that the wave was not only in this part of the oscilloscope, but it could go from up here to down here, the equivalent part of it. So it is throwing off all things that have to do with amplitude or that have to do with loudness. So it's a good idea to fix a DC offset right from the get-go, and that's what this plugin allows you to do. And of course, you have to do this manually. You have to eyeball it and get it to the right part, but it is definitely possible for you to fix a DC offset such that whatever you have will be centered around 0. And there is some techniques to do that. It has to do with filters, like high-pass filters that are very low. So if you have a high-pass filter at 10 Hertz, the cutoff frequency is 10 Hertz, then that fixes the DC offset. But that whole can of worms is not something I'm getting into. All I'm doing is this version that you can change by hand. And that's a DC offset for you. Now let's move on to the next one. And it's a bunch. I'm going to create a bunch of material that is stereo or multi-channel, and I'm going to mix it in different ways. So converting all the channels to mono, copying from left to right and vice versa, inverting left and right, a stereo mixer, these kinds of things that are utilities that if you have some signal that is broken in some way, you can just fix it easily. So let's start by creating something that allows us to check that we are doing the thing that we want to do. So I'm going to remove all these effects, and I'm going to create a setup here that is a stereo channel with different material on left and right, so we can tell if things are working or not. So I will have here three tracks, and 2 of them are going to be under the parent, yeah, like so. And this is going to be panned to the left, and this one is going to be panned to the right. Now on the left one, I'm going to put a tone generator. That's the one that comes with Reaper. We will create our own in a future episode. And it's putting out this note. And on the right channel, I'll put another one of these tone generators, but it's going to generate another note. And this way, and I guess this is too loud, so I'll bring down the volume on the master channel. And when I put on the headphones, I should hear different notes on the left and on the right. And of course, if you're watching this, you should be wearing headphones or have some kind of setup in which you can hear the difference between left and right, or this won't make any sense to you. Anyway, so let's unmute and see if we have something. Good. I can hear different notes on the different sides. So when I do all the shenanigans with the channels, I will know that I'm doing the right thing. So that's just the setup to test. The same way we had to create a broken white noise generator just to test the DC offset. Okay, so let's start with something that takes a bunch of channels and mixes them all to mono. And this is a new effect that I'm going to call mix down to mono JS effect. And I'm going to, first of all, get rid of the boilerplate. And then let's think about what this should do. It should take the signals on both sides and mix them down to mono. But I still want to hear the mixed down signal on both sides. And I want this to be multi-channel just because I can. So I'm going to do something on every sample, and I'm going to mix. So this is going to be the combination of all signals, and it starts with 0. And I'm going to loop through every channel and accumulate all the channels in the mix. And that's a concept that is how to combine signals. And you're going to see a trend in this episode. All I'm doing is just a bunch of simple arithmetic on the channels. So on the first one, on the DC offset, I took a signal and I added or subtracted a constant number, that slider. Now we are taking 2 signals and adding them together, and that's how you can combine signals. So I will loop through every channel with the same loop construct we saw before. And here in the mix, I will add the sample for that channel. Of course, when I'm done, I will be adding a bunch of signals, like let's say 2 signals. And they are between -1 and 1. So suppose that at some point they are both 1. I will end up with the number 2 here in the mix. Not what I want, because I want the mix to be still between -1 and 1. So what I'm going to do is divide by the number of channels, which in this case would be 2. So if both signals were the number 1, I would end up with 2. And by doing this, I'm dividing by 2. And I end up with 1 again. So this is normalizing the signal to be in the range that we want. And Now that I have the mix, what I want to do is to go through every channel again, but this time I am going to set the sample on that channel to be equal to the mix. So again, this is supporting multi-channel, and what it's doing is taking all the channels and setting them to the mix. So I'm going to hear the combined signal of both notes, of both tones, in both ears. Let's save this and come back to the main interface, and I am going to come back to the mixer, unmute, and what I expect to hear is both notes in both ears. Good. I'm going to unmute, and I'm going to turn the signal, the effect on and off, so you can hear the difference. And that's it. That's mixing down to mono. Now let's do another one that is just stereo, and it's an utility. You can see that these are utilities because they don't even have sliders. You're just putting them on the channel and fixing something and moving on. So this next one will be taking the left channel and copying to the right, because you only have signal that you care about on the left channel. And of course, you could generalize this to make it multi-channel, and then you could maybe have a slider to select the channel that you want. But I'll keep things simple and just replicate what I think exists in Adobe Audition and do this copy left to right and vice versa. So I'll do this copy left to right JS effect. And now what I want to hear on this one is the note that I was hearing on the left, I want to hear on both sides. And the note that I was hearing on the right, I don't want to hear it anymore. So I'll do something that looks like this. So I'll take the left channel, copy it to the right, and I'm good to go. So now let's close this and test it out. And of course, I want to disable this one. I will remove it. So I'll do the same thing again. I will unmute, and I will turn this on and off to see if we got this. There you go. Now let's create another one that is the exact opposite. So I'm going to again come here and find this effect. And is there a way for me to duplicate? No. So I'm going to copy this code. Though it's so simple that it may be easier to just write it. Create new JS effect and copy right to left and do the opposite. Let's test this one. How about we have both just to see if they are doing the right thing? So I'm going to come back here to my effects browser, and I'll have a copy left to right and a copy right to left. I'll disable both. Yeah, as you can tell, when I enable and disable these different ones, they are bringing the channels left and right. And just because I am here, I will do the other thing I mentioned, the one with the slider, and I will copy any channel to all channels. So I'll add another effect, create a new one, and it will be called copy channel to all channels. And in this one, I want a slider that will be channel to copy, and it will be 0 by default because that's the left channel. So by default, it will be equivalent to the copy left to right. And I want this range to be between 0 and 64 because in Reaper, a track can have at most 64 channels. And I want the increments to be of 1 because there is no fractional channel. So this will be the channel to copy. And on every sample, I will take, I'll do that looping. So I'll start with -1, loop the number of channels, and then the sample on that channel will be equal to the sample on the channel to copy. And now we have a multi-channel effect that does the copying for us. So again, I will bring in the volume and we'll see how it goes. And this track doesn't have more than 2 channels. So if I copy the values that are above 2 or above 1, then I'll just get silence in both ears. Fair. Excellent. Let's move on to the next one. Now, what we want is to invert left and right. And this is if you recorded something that is inverted and you want to fix that very easily. So I'll remove this effect and add a new one that will be called invert left and right. And I'll get rid of the default code. And on every sample, what I want to do is take the value of sample 0 and put on sample 1 and vice versa. So it's like a combination of both the copy from left to right and vice versa. So I'll take left equals sample 0 and right equals sample 1 and sample 0 equals right and sample 1 equals left. And the reason why I'm doing it this way is because if I try to do something like this, it wouldn't work. Why wouldn't it work? Because when I assigned sample 0 to the value of sample 1, then when I try to do this line, sample 0 is already overwritten. It's incorrect. So there are simpler ways to do this, or there are maybe, I don't think it's simpler. There are other ways to do this in which you don't have to have 2 variables. You could just have 1 temporary variable, but I think it's clearer if you do it like this. And now I will save this and I will disable or bypass it, bring it on. And there you have it. It inverts left and right. Now for this next one, what I want to do is a generalization of this, but for stereo only, but I want to generalize these ideas of mixing the channels. So what I'm going to do is a stereo mixer in which I'm going to let you decide the amount of signal on the left and on the right. And yeah, let's create a new one, a new plugin. And I'm going to call this one the stereo mixer. And again, get rid of the boilerplate. The setup is similar to the other one, so I will do this again. But now I'm going to have a bunch of sliders. Slider 1 is going to be the amount of the left on the left, and I'm going to use dB as the unit in this. So I want to preserve the amount, when you just load the plugin, I'm going to preserve the amount of the left channel on the left channel and amount of the right channel on the right channel. So effectively, it will be a bypass. It won't do anything. So I want to start with 0. And the minimum you can do is -60. Why not? And the maximum you can do is something like 12. And I will give you increments of 0.1 dB. So that is the left in dB. And here is the left to left. Maybe I should have a 2 here in the middle to make sense, to help this make more sense. So this is the amount of the left signal that is going to the left ear. And then I will have a bunch of sliders similar to this one. So now I will talk about the amount of how much of the left channel is going to the right channel. So it's left to right. And now the amount of the right channel that is going to the left and the amount of the right channel that is going to the right. So have here right to left and right to right. Let's double check. Left to right, right to left, right to right, left to left, left to right, right to left, and right to right. We are good. And when I am doing the mixing, I want to have the values, these levels in amplitude. So if you want to learn more about this conversion between dB and amplitude, I have a whole episode in which I explain a gain effect. And then I have another episode in which I fix some mistake that I made. But the point here is there is another episode in which I explain the computation between the conversion between dB and amplitude. So if you want to understand what's going on here in the formula I'm about to write, you should check that episode. So I'll have a bunch of these, and I want to get rid of all these parts. And I'll put some spaces here, just following the convention of JS effects, though there isn't really a convention, but I'm just following what I see in many effects. So what I'm going to do here is 10 to the power of that divided by 20. Again, if you want to learn more about why I'm doing it like this, then you should check that other episode. And when I do this, I get the value in amplitude. So let's now replicate this for all 4. Now let's check that we have the thing right, left to right, right to left, right to right, amplitude, 10 to the power of, left to right, right to left, right to right, all in dB, all divided by 20, 10 to the power of. Now we have these 4 variables to work with. Now what we want when we are creating the signal on the left is to have some amount of the left channel and some amount of the right channel. So I will create here the signal on the left, the signal on the right, and we'll have some amount of these plus some amount of that. And this is the amount of the left channel that is going to the left, and this is the amount of the right channel that is going to the left. And this is the amount of the left channel that is going to the right, and this is the amount of the right channel that is going to the right. Yeah, so it's the left times. Again, I'm doing the trick of assigning this to variables before I start, because when I overwrite this, then if I try to use sample 0 here instead of left, it would be overwritten already. So the same story goes here. So the left is left times left to left, and right times right to left. And the right is left times left to right. And yeah, left to right, and plus right times right to right. And there is a mistake here in the default values, because I don't want to send both signals to both ears all the time. Otherwise, I would effectively have a mono signal. So what I want instead is to have the left to left is going to be 0, doesn't affect the signal, but the left to right will be minus 60, which may not be enough. So what I'm going to do is change this 60s to be minus 200, let's say. That's going to bring it down effectively. So I'll put a bunch of minus 60s here. Oh, and this is in the wrong place. So yeah, what I'm doing here is left to left stays untouched, left to right, I will bring it down. Right to left, I'll bring it down, but right to right stays untouched. So now I'm going to do is I'm going to open this on an external editor, and I'm going to replace every occurrence of minus 60 with minus 200, which is as good as muting it. And I'm done. And I save, close, come here and reload. So let's see what this looks like. I have here the sliders, and I'll bring them all to their default value, or I could just reset to factory default. And now I have all these. You know what? I don't like this arrow. I think that JSFX has... I think I kind of proved this in another episode, that it has support for Unicode, and I used this to create a slider that you couldn't see the label for with non-breaking space. That is in the episode in which I'm fixing mistakes from the past. I do that in the oscilloscope. I'm going to open the external editor and change every occurrence of this arrow like so to the Unicode representation of a right arrow. It looks like this. Replace all. Done. Now, I am sure that JSFX support Unicode. What I'm not sure of is that the font that is being used to render this has support for this character. So it has support, it works here. Let's see if it works here. It doesn't seem to. Oh yeah, it does work. It does work. So now we have nicer arrows. And let's bring now the signal again and test this out. So I'm going to unmute and I'm going to play with the signals and see what we get. Okay, so first of all, when I just enable the plugin, factory defaults, it doesn't do anything. Good. Now I'm going to bring up and down the volume and see if that has effect. I forgot to enable the plugin and I was like, this isn't working. Okay, I will enable the plugin and try this again. Resetting this to factory. Doesn't seem to work. Okay, I'll double click everything. Now it's in the factory defaults. Plugin is not bypassed. Let's try this again. I'll bring the volume slightly down because it's kind of annoying. So now you can see how this plugin kind of generalizes all the other ones. If we want to invert left and right, we just bring up the volume of left to right and right to left. If we want to copy, we bring up the volume of left to left and right and left to right, and so on and so forth. So this is the stereo mixer. It does everything that the previous ones do. Enough of the stereo mixer. It's working. I will mute this again, and let's move on to the next one. The next one is still in the trend of doing signals that are just adding and subtracting signals. Still on that trend, I'm going to create something that does null testing. The intent of a null test is to put two pieces of equipment or put two audio effects or plugins or VSTs side by side and compare their outputs. Maybe you have two compressors and you want to hear the difference between the two compressors. Maybe one compressor is one that comes for free in Reaper or for free in some website, and another compressor is $200, and you have a trial version and you want to see if that's worth the $200. Maybe it's just advertisement and a good user interface, some shiny graphics, but the sound is the same. And no one is going to hear your beautiful graphics. They are only going to hear what you produce with sound. So that's the null test is a good way to be more scientific about the comparisons and the measurement of different plugins and different equipment. So the idea of a null test is that we are going to get two signals and we are going to see their difference. One signal coming from the compressor that comes with Reaper, one signal that is coming from your $200 compressor, and we're going to see the difference between the two signals. And okay, so let's get started. I will add a new plugin that is going to be called a null tester. As always, I'm going to start by getting rid of this sample code. And what I'm going to do is just take, to begin with, I guess what I should do first, before I even start working on the code, is to have some setup so that this will do something that we care about. So I'm going to change the setup on the tracks here. I am going to disable this effect. So now we have nothing on the right channel. And I'm going to duplicate this track. So now we have the same signal coming to the left and the right. And what I'm going to do is flip that signal. So whenever the signal is 0.7, it will be minus 0.7. And whenever it's minus 0.3, it will be 0.3. So it's flipping the signals by using this, invert the phase. Now the signals on the left and on the right are exact opposites of one another. And the null tester is going to be able to tell that the signals are the same, or at least they should be, because they are generating tones with exactly the same frequency. So now we have here on the setup, if we hear this, it will be the same node. We won't be able to tell this with our ears, but with an oscilloscope, we could set things up to show this. Okay, let's come here to the mixer and I will show you the signal. Sounds the same in both ears. And I will bring in our oscilloscope. And I'll put the oscilloscope in both channels. Oh, but it has to be after the inversion of the phase. So I don't think that I will be able to show the inversion because this oscilloscope is going between the tone generator and the thing that does the inversion of the phase here. So that won't work. I will be able to show this after we create an effect that does the inversion of the signals, that does effectively what this is doing. But that's coming up next. So now we just have to trust that this button here is doing what it's supposed to, and it's inverting the phase of the left channel with respect, inverting the phase of the right channel with respect to the left channel. Okay, with that setup, we can use the null tester and we can start writing some code. So what I want to do is just take the signal is going to be, of course, I want to run this on every sample. So the signal is going to be the sample on the left minus the sample on the right. And let's save this and see what we have. Oh, the signal is this. Now we want to, of course, put this in both ears. So sample 0 equals signal and sample 1 equals signal. Okay, so now let's see how this is behaving. It's definitely bringing the volume down, but it's not exactly muting it as I was expecting. I was expecting this to be exactly out of phase, so it would exactly do an inversion. So maybe what I have to do, it would exactly do a complete cancellation. It would take, this value would be minus 0.7, this would be 0.7, and then I would add them up in the null tester. I would subtract them, really. Oh yeah, that is it. I am doing things that are out of phase, so you won't be able to, they will not cancel out, because this is like, being out of phase means that these two plugins are not outputting the same, so they should have some signal coming out. So I got mixed up here. What I want is, when I turn this off, then the combination of the two signals should be canceling out, because these two tracks should be generating the same signal on the left and on the right, which is not happening. So what I'm going to do instead is change the setup of these tracks. I'm going to delete this track because it's not doing what I wanted. And I'm going to take the signal from, and I'm also going to delete this track. No, I'm going to keep it around because it will be useful for the next effects. But what I'm going to do is change this so it's not panning to the left or the right. It's actually right in the center. And I'm going to take the signal from this track and send it to, in fact, I'm going to take down the mixer for now. And I'm going to take the signal of this track and send it to this track and to that track. And I don't want to send this to the parent. So now this track is only heard through these two tracks. The wiring is like this. Let me show the track wiring. So what happens is track number 4 generates a signal. It doesn't send it to the parent. You can see there is no cable here, but it does send it to tracks 3 and 2. And tracks 3 and 2 are sending to the parent. And we should be able to hear that. On the master, but we are not. Why would that be? You know why? Because the null tester is doing its thing. Because it's exactly working. So now that I have the null tester here, it's taking the signals from the left and the right, and I disable it so you can hear it. But they are exactly the same signal on the left and on the right. So when I apply the null tester, it just cancels out. You can see that there's some signal coming in, but no signal going out. And there is a trick here that I want to do, and that is on channel 2, I want to have the thing pan to the left, and on channel 3, I want to have the thing pan to the right. And now this is the setup that I wanted. It's the same signal. So what was happening before when I had the tone generator in both tracks is the timing was slightly off, because when Reaper is running effects, it may run them in different orders or do any kind of crazy thing. So they were not exactly parallel. But when I take a signal like this and I send it to 2 tracks, and then I put them on the right sides, then this is exactly the same signal and they are synchronized. So this is a better setup to test the thing that I wanted. So now, with this, what I can do is test make sure that the null tester is working, and it is, because it's taking the left and the right and it's muting. So let's hear this. No signal. And some signal when I disable it. So this is making sure that your compressor that comes with Reaper and your compressor that is $200, they are producing exactly the same signal, and now you can tell. What if they are not producing the same signal? Well, that's what we just saw before. Then the null tester will output some sound. And usually it's not a pure sine wave like the things that we are using to test. Usually it will be garbled and probably quiet. It won't be too huge of a difference, but you can just look at the meters and trust your ears. If you are hearing a lot of low end, then the difference between the compressors is in the low end, and so on. But you can also trust the meters. If the difference is around here in this area between 0 and minus 60, it's something that you can definitely hear. If it's between minus 60 and minus 90, then You would be able to hear it if you crank the volume way up and then try to hear it. But for real, in a mix, you won't be able to tell. And if it's below like 140, then forget about it. No one is, or maybe even 120, no one is going to be able to hear it. The two compressors are equivalent. And of course, I'm not only talking about compressors. It could be any piece of gear. It could be an equalizer. It could be some literal hardware. Who knows? You're just comparing the signals. And that's what the null tester does. And I want to generalize this so that it works with any number of channels. So in this case, I am specializing it here, and it works with stereo channels. I'm going to mute this because I'm writing some code now. So this is working with stereo channels, but I want to have this work with any number of channels. So if I have, let's say, 18 channels, I'm going to consider that you have two signals that are 8 channels on the left, 8 channels on the right, and you want to compare the two. So you can even compare multi-channel signals. So what I want to do here instead is I am going to loop through all the channels. So I will have here channel. And now I want to compare the two signals. So I'm going to consider that there are two signals. So I'm going to say that this is the channel in signal 1. And that is -1. And I'm going to loop. But this time I won't loop through all the channels. I'll loop through the number of channels divided by 2, because that is the number of channels that you will see, that you will hear in signal 1. And of course, I also need to do the same for the channels in the signal 2, the thing that is going to start in channel 8 and on. So I'm going to do the setup for this loop into parts. Channel in signal 2 is the number of channels divided by 2. So the number of channels here is, for instance, in this case, 2. 2 divided by 2 is 1, which is exactly what we want, because, oh, actually I have to have -1 here, because then when I add here, so yeah, 2 divided by 2 will be 1, -1 will be 0, and then when I start here, when I start writing code here, the channel in signal 2 will be 1, because that's 0 plus 1. And now I can do the comparison between the channels. So I will do sample in channel, the signal in channel 1 minus equal the sample with the signal in channel 2. And I don't want the signal in channel 2 to output at all. So you are going to have, let's say, 16 inputs and only 8 outputs. So I definitely want to take this and zero it, so you won't hear any, it won't produce any sound there. And this is going to slightly change what we saw in our previous example, because previously we were outputting the signal to both channels, but now we are not. We are only outputting to the left. And in this case, if you have mono signals and you have 2 of them, like we have here, we have mono signals, 2 of them, one on the left, one on the right, then you will hear their difference only on the left, because you only have number of channels divided by 2 outputs. And let's save this and see if this is still working. And I guess it is, because when I turn this on, there is some input coming in, but no output going out. And if I do the trick of inverting the phase, just let's invert the phase on the left, then we hear some signal. And that signal represents the difference between the signals. So yeah, when I invert the phase, they are no longer the same compressor or equivalent compressors. So you definitely hear some output. And when I turn it on again, you won't hear anything. And I will not put in here I will not let you actually hear this. Well, why not? I'll let you hear this, but I want to bring the volume down. So now The two signals are the same. You don't hear anything. When I invert one of them, you hear the difference between the signals on the left. And this is something you can use to test any kind of signal. If you have stereo signals, then what you would want to do is come here to the routing of the parent. Let this be a 4-channel track. Mute. Let this be a 4-channel track, and then I don't have to pan to the left and the right. I can leave this centered, but I do want to change the route such that this track is sending to channels 3 and 4. Now, if I disable the null tester, then there is some signal coming from track 2 here, stereo signal, some stereo signal coming from track 3 here, and when I enable the null tester, they all go out. The channels 3 and 4 go away because I'm enabled in the null tester, and null tester is always going to mute these tracks. It's always going to set them to 0. But more importantly, there is no signal here on the first 2 channels, and that is because the signals were exactly the same. So because they are exactly the same, they cancel out in the null test. And I'll enable this just so we can hear it. No signal at all, and when I invert, some signal. So there you go. That's an utility for you to test and compare different equipment. Okay, so this video is already too long. I'm going to stop now, but there is still a lot more that I want to cover. So this will be part 1 of probably 2, maybe more. And I still have mid-side encoding and decoding and gain and invert phase. We are going to create an effect that reproduces this. And then an enveloper and rectifier, a limiter. There's still a lot more to come, a lot more of these tapas, these small utility effects. But for now, thank you for watching. And if you want to learn more about JS effects and see me coding all the effects that I mentioned and many more, you should subscribe to this channel. I also output videos about things that I do in Reaper that help me out, different workflows. I also produce videos about programming in general. So if you're interested in that, make sure you subscribe. And if you liked this video, please hit the like button because that helps. And thank you for watching. I see you on the next one. Bye.